All right. Okay, if you guys go ahead and to chapter 9, please. There's a few things in chapter 9 I'm going to highlight, Ashley. These things directly related to street, road, highways, before we move into the into room cavity ratio and so forth. So, if you guys remember, we talked about parking lot lights before and how the foot candle and so forth. Um, Visual has a component. I know, Jackson, you guys were asking me about, there are three components in visual when you order it. One of them is professional, one is basic for the babies, and the third one is roadway, right? And some of you asked, Chad, what do I need to do with this one? I said, if you do highways, streets, you ask Lithuania to send you a license for this, and you should be able to, I don't have a license because we don't use it. You should be able to use sizing lights for roads, streets, roads, interstates, highways, and so forth. Cool? Everybody knows where we are? A couple of things I want to highlight. I picked these guys for you from directly from your book, chapter 9. There's a couple, so everybody knows that we're talking about streets and roads and highways and so forth. We're not talking about parking lots or indoor lights for this chapter. When we do this one, when we do this type of lighting, the first thing you need to pay attention to is what type of a road or interstate or a highway that you're dealing with. Are you dealing basically with a residential street versus are you dealing with a commercial boulevard or a commercial street? Especially residential commercial, guys, big deal. Or are you dealing with highways? So for the most part, and I'm not an expert in streets by any means, for most part, the first thing you're going to ask yourself, Rob, my friend, when you deal with roads is, what type of a road am I dealing with? Am I dealing with a street in a city streets, like residential? Or am I dealing with a commercial street in a city? Or am I dealing with an interstate highway, right? Or any state or interstate highways? Cool? Everybody knows the three dividers, thumbs up, Chad, we know that? So that's a major division between the three of them. Why? Because if you're doing highways, there's certain things you have to pay attention. Glare is one of them. If you're doing streets, another major thing you have to pay attention is pollution, light pollution. Chad Curdy and his wife are sleeping in Bloomington. I don't want you to put the light right through my bedroom, so people get mad. A lot of cities, guys, especially Bloomington, have restriction. I don't know if you guys use it or Nick, you guys do lighting. When you do lighting, a lot of cities have restrictions on the amount of light that you can spill on the people's properties, especially residential. So you have to pay attention to this one, especially in my understanding. Bloomington is really tough with that one, so you have to send your calculation to them with they call it 100% cutoff. So when you do a street, you have to make sure you don't, and they go there and they measure the actual foot candle on the people's property. And if it exceeds certain values, they might ask you to change the type of the fixture you're using there. So a couple of things to pay attention to. Is it residential, is it commercial, or is it industrial? That's really the major thing. If it's residential, we're worried about the spill, right? Well, light pollution, so-called. If it's commercial, we're worried in a commercial street. Anybody can tell me what the issue in a commercial street? Safety. In a commercial street, guys, if you have a sidewalk, most of commercial streets have a sidewalk. You want your light to throw the light at the commercial street as well as throw a little bit back at where? At the sidewalks, most of the time. If it's a commercial street, usually you have some type of sidewalks that you need to lit. So see that the difference? So you need to spill some light on the streets, on sidewalks. Highways, major part of the highways is glare. You don't want to disable the vision of the people as they're driving down 35W or 94. So that's a major thing. So any question guys about the three things, residential, commercial, as well as highways? Industrial comes somewhere between with the commercial too. So that's basically the three major divisions you have to do. Most of the time, guys, what they do for lights, you've seen them all the time. I do a little bit of a light here. Most of the time in the residential, you're going to have probably 10 to 12 foot in residential. It sits back 3 feet. They sit them back 3 feet on the property, and they throw the light. They have 12-foot pole, and they throw the light right in the center of the street to give you the light. And all the light have to be projected forward if it's a street light. Okay, a couple of things when it comes to road lighting you have to be very, very aware of. Number one is called glare. The glare comes into two types. The glare, guys, comes into two types. One type they call it discomfort. So it makes you feel bad when you're driving. Discomfort is okay. The bad, that's discomfort is one thing, but disability is a completely different thing. When you deal with highways, remember, you are behind the wheel driving at night. The last thing you want to do is to have HID light shining right through your eyes so you can't see anything in front of you or to your sides while you're driving. So when they designed the lights, guys, for the most part, they put them in a situation where the light is not shining directly at you, indirectly. So that's really the most important thing is glare. There's a net. If you do street lights, the software, the component that does the street light, they actually calculate the glare for you. They will tell you if you situate this fixture right in this location, this is the amount of glare that you're going to get versus if you orient it the other way. If you guys look at the highways when you're driving, most of them are oriented this way, they're shooting down. You barely can see one. If I'm driving this way, you would never see a lighting fixture shining right at your face. So these are the things that you need to pay attention. Glare. Can I get you to understand that glare comes in two forms? Discomfort, we can live with that, which a lot of lights, guys, create some type of a discomfort for us when we're driving, right? Especially when you get older. The other one that we want to eliminate is disability. We don't want to disable the vision of the person as you drive down the highway. Any question, guys, about disability as well as discomfort for glare? Questions? Okay, I picked a couple of things about poles, guys, and pole locations. Poles and pole locations, I threw a couple of things here for you. We have, if you're doing residential, most likely you're looking at 10 to 30 feet for residential. If you're doing highways, you can go as high as 75 foot on the highways. You see them, guys, all the time. There's a picture in your book. You can go 75 foot light on your highway. So these are just a couple of ideas in the commercial and in highways and commercial building. You can, or especially interstate, you can go all the way 30 to 75 for your street and the highway. I wanna show you the types of. Okay, I do have him here in a second. Okay, so that's basically, I threw a couple of things here. Sit back. We talked about the sit back right in here. You usually sit back in residential, you will be sit back 3 feet or so forth. So you put 3 feet and you put the pole and you set your pole and then you throw the light right to the center of the street, right to the center of your street. So any question guys of the pole? Most of the poles in residential 10 to 30 height with a base, 3 foot base usually, if it's especially commercial. In a highways, in a commercial, as well as in interstates and so forth, you're looking at 30 to 75 foot high. The higher, what's the problem with the higher? Everybody knows what the problem with the higher the pole. What's the higher the pole? The higher the pole, the less we can control the spill of the light. If you have a shorter pole, guys, you can control the distribution of the light better. So why do you think in residential you have a shorter one? Shorter one, I can make sure that all the light is thrown right at the street and not at inside somebody's bedroom. Any question about the poles? 10 to 30 residential, 30 to 75 highways, and there's a lot of combination of all of the above. Wood poles, steel poles, concrete poles are commonly used in all these applications if you were to use them. Okay, any question about the poles? So everybody knows that you're going to pay attention to where the street is located or the roadway is located first. The glare, discomfort, and disability. The poles, 10 to 30. The lower the pole, the more I can control the spill of the light. That's the most important thing. The higher the pole, though, the more light I can cover bigger areas. But there's a drawback, though. You put a 30 foot in a residential, guys. A two-lane street residential, you know what's going to happen at 30 foot? You're going to shoot the light right through somebody's window on the other side. You can't control the spill of the light. You're going to have so-called light pollution. Light pollution. A lot of communities, guys. The one that I live in, the street that I live in, they only have lights on intersection. They don't want, the people don't want lights on the streets, just the intersection. Every intersection you'll find a light, but in between, people don't like a whole lot of lights. It annoys people, especially residential. Okay, fixture type. This is where I want you guys to wake up. There are 3 types of fixture distribution. This is light distribution patterns. They call it 1, 2, and 3. I want to show you what that means, 1, 2, and 3. When it comes to streets, is a big deal because of 2 factors. When you're doing streets or roads, guys, there are 2 major factors. Number 1, I do not want to spill light on the customers behind me or in front of me as a light. I'm shooting light this way. I want all the lights to go right in the middle of the street only, not to the customers in the front of me or the customers behind me, the owner of a house in front of me or behind me. The second thing you have to pay attention to, if you have street lights too, especially commercial, they have sidewalks for people to walk from place to place, and some residential also have sidewalks. If you have sidewalks, you need to put a fixture that allows you to throw a little bit of light on the sidewalk so people can safely walk. Does that make sense? So that's because of all these factors, they have type 1, type 2, and type 3 light distribution patterns. And I'm going to show you these patterns. Okay, so these patterns of the light distribution. Here's type 1, guys. And again, feel free to disagree or agree with Chad. So here's fixture type 1. And you buy the fixture. This is by the fixture that you type. So if you type, when you guys remember when you were doing a parking lot, you were looking, they were telling you, you know, these 3, 1, 2, 3 distribution patterns. And if you pick one, it shoots this way. If you pick the other one, shorter. So we're talking, everybody, you guys agree that we are talking about the distribution of light, right, in this area. Distribution of light in this area. Take this, fixture type 1. Mostly residential. Look at this stuff, guys. It's when you set it back 3 feet here, and you put it at a 10 foot pole, the light will shoot and spread. Can you guys see how it spreads a little bit? The type 1 will spread to give you a full coverage of the 2-lane light, 2-lane street. But it doesn't spill light behind or further. Behind, it has a what they call it 90% cutoff. 90% cutoff, it will shoot from here all the way to the end of the street. It doesn't go to the neighbor's yard. 90% cutoff. So that's type 1. Again, mostly residential. Mostly residential. Now they have a lot of different types that you can orient them, guys, to do anything you want. Okay, type 1. Any question, guys, about type 1? Why type 1 is cool? I have a 2-lane street like this guy, and I mounted. Look where my picture is mounted through an arm, right at the top of the middle of the street almost, and it shoots the light right into the middle of it. Perfect for residential. Then Chad Kirby is sleeping, he and his wife, and will not be disturbed by the light. Okay, type 2, commercial and 2-lane roads. If you have 2-lane in every direction road, 2-lane in every direction, that's a commercial. Commercial 1, guys, so it shoots more. Can you guys see if you have 2 lanes in every direction, you need a fixture to shoot further. So this one, it will give you more light. And all these guys are in your book. You can look at them too. If you look at type 2, it's typical like type 1, but it shoots more on the other side because it's commercial or 2-lane highways. So we're not worried too much about it. The last one is 3, commercial. The nice thing about the 3, guys, it shoots, you want it in a commercial street, or you want it to shoot. So here's a couple of, lanes here. So you have a couple of lanes going on here, and you want a fixture right in here that can lit the sidewalk, the street, and the other sidewalk in the other end. So it gives you more. It doesn't have 100% cutoff or 90% cutoff. So it gives you more distribution of the light forward, more forward distribution. This one gives you sideway distribution, this way. This one in particular, exactly the opposite of the residential. It shoots straight forward, so it can cover the 2 lanes on the street as well as the sidewalk. where the fixture is located and across the street. Any comments about these three types? When you guys do, if you do sidewalks, if you do streets, when you get that little software, as you grab a fixture, make sure you pay attention. Every fixture will have in the name, like we did the parking lot, it will have an eye, or two eyes, or three eyes, or 1, 2, 3. So can I use any one of them anywhere? Yes. If you situate it right with the right, orient it right, you might get away with number 2 in a residential, but most of the time, if you're doing residential, number 1, if you're doing commercial, multiple lanes is number 3, and number 2 is somewhere in between. That's how I think about it anyway. Any comments, any questions? Nick, my friend, any comments, any questions? So really, that's the major thing, the 3 types I want you to know. What's on the streets? This is just a couple of things, guys. When it comes to street, the watts that you can put, actually in residential, you probably put 175 for highways, or you probably can go as low as 100. From 100, watt-wise, from 100 all the way to 400 most of the time. If you do highways, this is for not homework, highways. If you're doing highways, they can put 1,000 watt luminaires, guys, in these big towers, 75 foot, to lit the whole area. So they have big. They can use, what do you use there? You can use metal halide most of the time, or high pressure sodium. These are the 2 fixtures that commonly used in highways, roads. Metal halide, high pressure sodium. Metal halide, high pressure sodium. So this is just a couple of watts that you can pick on. And you guys, when you did the parking lot, actually the parking lot exactly like doing residential streets, almost the same. Now you get into a commercial street, you have to pay attention a little bit more to the sidewalks. And if you're doing a highway, you have to pay a little bit more to the glare, because you don't want people driving down, as I said, 494 at 75 miles an hour, and they're blinded by this light. Foot candle. When we do, you guys did it with us, they always go by minimum. For the most guys, the minimum is 0.5. They don't want you in a street to have less than 0.5, right? And the ratio average to minimum, highways, they have a ratio. This is my highway. This is my residential. Highways 3:1. Again, these could change and updated. Highway 3:1, 6:1 if it's residential. 3:1, 6:1 if it's residential. Everybody knows what the ratio between average to minimum. This is it gives you how the difference between your average brightest spot compared to your darkest spot, right? Obviously 1-to-1, Nick, is the perfect, means it's evenly distributed light. You can't get 1-to-1 unless you spend a lot of time and money on designing it and installing it. So these are good rule of thumb when it comes to lights. Now I want to remind you, Ashley and Rob, my friend, that we have used a visual, and you guys have picked fixtures. We picked the CAD fixture. Remember that CAD fixture that we picked? We picked the CAD fixture based on these criteria, which is 1, 2, 3, type 1, 2, 3 distribution. Parking lot, probably you are, if you're doing parking lot, you're type 1 or type 2. It depends. If you own the whole area and you have a sidewalk around your premises, you might go to type 3, because you want to spill on the sidewalk around your premises. If you're close to residential, if you're a business close to residential, most likely you're doing type 1 or type 2. Any question, my friends? Any question? And the last thing, if you guys look, when we were doing a parking lot, you have an isofoot candle that you can do. So if I put my fixture right in here, and it will show the isofoot candle that this fixture is going to be covering right in here. And if I need another fixture right here, the isofoot candle of this fixture will overlap, like we did with the parking lot. Remember how we did the parking lot? You put your fixtures to overlap, Isofoot candle. Isofoot curve, guys, is a curve that connect all the points on that street or roadway that have the same foot candle. So if I go to this point here, this point, and this point, most likely is going to be the minimum, 0.5. I don't want it to be higher than that. If I go right in between them, right here, that curve, let's just say represent 1 foot candle. And the closer you get, that curve will represent 1.5 foot candle. The closer to the fixture you get, for the most part, the more light you're going to get. The further away from the fixture, the less light you're going to get. Any question about street highways, street lighting or road lighting? That's all what I have about this chapter. I want to remind you guys, if you have your book in page 74, they have the 3 types. If you guys want to pay attention to this chapter, just page 74, 9.1 give you the distribution 1, 2, 3. And also on page 73, they give you a couple of lights. Let me see if I can get you, before I move to a different topic, let me see if I can get a couple of lights. Okay, manufacturers. What am I here? Manufacturers, SCADA system, lighting system. Let's go to Lithonia. Acuity brands. Just go to Lithonia and see, grab a CAD and show you a couple of things about that. Okay. Acuity brand. Let's go to Lithonia just because we're familiar with that. Okay, so Lithonia. Okay, let me see what we have here. Lithonia lighting. Where's the product? LED outdoor lights. Do we have street here? It says indoor lights, outdoor lights. I think I don't see roadway. Outdoor lights. Outdoor lights. Parking lot, driveways. Most of these are parking lot and driveways. So I want to grab just a parking lot because similar fixtures. LED is a big deal now. Let's look at CAD. This one is a fixture that could use, it's an LED fixture. CAD fixture LED. Okay, let me just see the specification sheet about this baby. Okay, let's just look at the specification sheet about square feet and so forth. And you guys can get the IES file about this fixture in visual and use it anytime. I'm just going to throw this. Okay, here's a CAD fixture LED. Construction, ideal for parking areas, street. Can you guys see where it says streets and walkways and car lots? Everybody can see that? So this bit, it's an LED, CAD LED, ideal for streets. Let's say the vertical. A couple of things about this fixture you can buy. You guys have looked at these. Ashley, I want you to look at the types here. You have type 5 too. Here's type 2, 3, and type 4, and type 5. And I showed you type 1, 2, and 3. There's type 4 and 5. There's another distribution. Don't even have a picture of these, but they can get you. Here's the distribution pattern. So when you're looking SR2, SR3, SR4, SR5, if you're looking probably residential, you're using SR2. SR3 is commercial. So it gives you the whole distribution. My whole goal here is just to show you where the type is. You guys are familiar with the multi-voltage. You can get it multi-voltage. You can mounting height, the type, the length of the arm that you can put it on the pole, a couple of other things. Let me see if we can have lighting facts. So anyway, so that's number of lighting, total number of LEDs. Okay, here's a good. If you are using SR3, here's how much lumen you can get out of one light, guys. So they give you more information about this lighting fixture. But really, my only interest here of this fixture is the distribution pattern. Any comments? Any questions? Can I have a thumbs up, Chad? Yeah, we got it. We're cool with that one. You guys have used visual. The only thing I can see, pay attention to the 1, 2, 3, and they have multiple distributions. And if you don't know, even if you don't know, when you guys drop the contour line of these fixture, you will see that this fixture is throwing too much light in the back. I need a fixture that throws less light. Okay. Any question, guys? Any comments? Any questions about that? I don't want this one. Okay. Okay, so let me, I don't know if we have, I don't have the highways for me with visual. Is professional, site visual, I don't find that. Okay, no exterior. This is the exterior. Okay. Anyway, I don't want to. You guys are familiar with the calculation for it. Any comments? Any questions? Comments? Questions? So that's what I want you guys to know about lighting. Again, if you Rob, which one of them? This is the highway. There you go. Software activation, lighting visual for 30-day trial. Activate roadway visual. I don't want activated. I don't want to activate it. This one is my trial period has expired. You guys, when you downloaded visual street lights, if you hit on software, the one that says street here, roads and streets, visual roadway lighting system, mine expired. If you they get you 30 days and you get your license if you're going to do streets. I encourage you strongly to use this component for one reason: give you glare. It's much better. It's geared towards streets, not parking lot. If you're doing visual professional, great for parking lots and indoor lights. If you go outdoor lights, you're going to be using this component, and you guys have it. Okay. Any comments? Any questions? What I'm going to do, guys, I'm going to give you 5 minutes, and I'm going to switch track into doing indoor lighting calculation by hand using the ceiling cavity ratio and the floor cavity ratio and a bunch of other ones. So, okay, can you guys do me a favor and switch track to where am I here? Okay. Why are we stuck here? Just going too fast. Okay. There you go. Okay, can you guys do me a favor and switch to chapter 10, please? This chapter 10 is really a few things I want to highlight in that chapter. Thank you, thank you, thank you. Okay, when we do, guys, when you guys cool? Tom, my friend, when we do, now we're moving from streets into indoor lighting. When we do indoor lighting, guys, we have to take into consideration two things. As we said before, when you do indoor lighting, you have to take the direct lights into consideration, the light that comes out of the fixture right at the top of Dustin head here, and also the indirect light, the light that comes from the fixture, bounce off the wall and hit the illuminated floor. That's why when you do indoor lighting calculation by hand is slightly different than the calculation that you can do for outdoor lights, because outdoor, for the most part, you do not have walls to bounce off. So a couple of things I want you to remind you: when we do indoor light calculation, there's a cavity zonal cavity ratio, they call it, zonal cavity, that we need to go over in a second here. So the only thing I want to mention is, when we do light calculation, you have to take into consideration the light that comes out of the fixture, number one. Number two, the light that's reflected from the walls, reflection from the floor, ceiling, and walls. Reflection from the floor, ceiling, and walls. Thanks God for visual and AGI and all these softwares. We don't have to worry too much about it because we know how to use them. But I want to show you guys one example in your life how to do it by hand. What I'm going to show you is not what you're going to do in the industry. You're going to have a software like we have done, and you're going to calculate it with using a software. Now, just to appreciate what the software is doing, what they do is when you do indoor, you have wall, ceiling, and floor of any area, right? You're going to have wall, ceiling, and floor. You're going to have reflection of this walls, ceiling, and floor, cubic. So again, direct light, indirect light, we have reflection from the floor, the ceiling, and the walls. For the most part, the floor, guys, is kind of almost negligible. We use the floors and the ceiling to reflect the light. Okay, can I have a thumbs up, Chad? We know that direct, indirect light, and we know where the light is reflected from, right? Cool. Thumbs up. Rob, my friend, cool. Okay, so reflected from floor, ceiling, and wall. So we're going to show how to allocate this one in a second. The second thing is also for lighting fixture, there's called light loss factor. You guys were assigning a 0.82 for the fixtures that we use in Lithuania for the luminaire fixture indoor. That's based on experience. That 0.82 is a good light loss factor. When they do the light loss factor, they take into consideration light depreciation factor, lumen depreciation factor. There's a bunch of other factors that they have here that take into consideration. I grabbed them from your book. They're all lump sum, ambient temperature factor, a couple of ballast factor. So there's a couple of things that they take into consideration. And bottom line at the end, guys, when we did our calculation, we came up with, we assign a light loss factor of 0.82 for every fluorescent 2x4 fixture that we installed in our project, based on all these factors that we have. Calculate the light loss factor. If you guys go to page 83, you have to take into consideration the ambient temperature. Fixtures love to work at a certain temperature. You go higher or lower than their ambient temperature, they will lose lumens. So ambient temperature, there's the ballast factor, they say BF. So ambient temperature is 80. Everybody can see the 80 is ambient temperature. BF is a ballast factor. Poor ballast or good ballast and so forth. Room surface dirt depreciation. Room surface dirt depreciation, how dirty the room is. Not a fixture this time. Remember, the fixture has its own dirt depreciation factor. Now the room, how dirty the walls are. Room and the ceiling and the floor, because if it's dirty, it's not going to reflect that much light. So room surface dirt depreciation. And then light lumen depreciation factor, that comes with the lumen, because day one, the lumen, 3,000 lumens. A year from now, you're not going to get 3,000 lumens. It just ages, and it's not going to give you that lumen. So LLD, LDDF, the dirt depreciation factor, room surface depreciation, we got that one. Lamp lumen depreciation, LLD, and we have lumen dirt depreciation. Lumen dirt depreciation is another factor that we have to take into consideration. So all these factors, guys, LDD, LLD, AT, VF, BF, and RSDD, all of them are in page 83. Explain what they are. One more time. Ambient temperature is AT, is ambient temperature. Voltage also, VF, voltage factor. The voltage, if the voltage varies, it will affect the performance of the fixture. So you have to take this into consideration. Ballast factor is BF. What else do we have here? Room surface depreciation factor, RSDD, and lumen depreciation factor, LLD. And the first one is lumen dirt depreciation. Lumen dirt depreciation. All these are factors. Lumen dirt depreciation. All these are factors that affect the light loss factor. So all these guys are in your book. So it's I just put the symbols on them. Obviously, I'm not going to tell you the dirtier the place is, the worse your lighting system is, right? The hotter the space is, or the colder, the worse your lighting system is, meaning you need more lights to get you the same amount of foot candle. Can I guys get you to understand two things, please? Number one is when we do indoor light, we have direct and indirect light coming to the surface. And number two, this is what affects any lighting fixture, especially a lighting fixture indoor. All these factors. Anybody have any question about these? How do they affect and how much they affect? You guys look at your book. They have for example, room surface depreciation factor. If it's very dirty, they have a list here. If it's very clean, they give it 0 to 12% factor. Clean. If it's very dirty, you can get it to 60%. Be very careful when you use it though. You might have to use the opposite. Use if it's extremely dirty, it's 0 basically. If it's very clean, it's 100%. So it doesn't affect your numbers. Doesn't affect your numbers. Okay. Any question about this? Can I have thumbs up that we know the LLF and we know the direct and indirect lines? So we can go into so-called zonal cavity calculation. That's what I really want to go into zonal cavity calculation. Take this. There's something called zonal cavity calculation, my friends. This is what the software is doing. When visual does the calculation for you, right here, guys, when you see all this calculation that you have done in the wall of this area, where's my zoom area? Zoom area. There you go. When you do the calculation, it takes into consideration the light coming out of the fixture, bounce off the wall and hitting the floor, right? So this is basically what we're going to be doing. If you look at the zone cavity ratio right here from visual, this is directly from visual. This area, you divide the space into 3 locations. Location number 1 is the calculation zone that we put at 2.5. So this level is going to be 2.5. Most of the time, this level is also 2.5. The second level is above the suspended ceiling, guys, right here. And in between 2.5, give me 5. So if I have a 12-foot ceiling, typically that will give me 5, or will give me 7, right? That will give me here 7. Okay. Any question, guys, about this? This is directly from your visual. So because of this, actually, they call this area here, this area is called floor cavity ratio. Or floor, they call it floor cavity, and then they find a ratio for it. This area is called floor cavity. Let's just add the ratio here. This area here is called room cavity ratio. And what do you guys think the top one is going to be called? This area is called ceiling cavity ratio. Can I guys get you to give me a thumbs up? We understand what at least the definition of the area is. The floor from the floor up to 2.5 is the floor. Between 2.5 to 9.5, right? That will give me the room, and above 2.5 all the way to the ceiling. My ceiling in this case, guys, as you can see, is going to be a 12-foot ceiling, right? 12-foot ceiling. Any question? Now, Rob, the only cavity that I want you to pay attention to that used for the calculation is the room cavity ratio, the red, because I care less about what's happening above the suspended ceiling, or even if you don't have suspended ceiling, you suspend the fixture. Above the fixture, I care less to see what's going on for the most part. Number 2, I care less about what's going on in the floor, because I would never lay on my tummy here and do my work at Dunwoody, laying on my tummy on the floor. Now, if you're doing at home, if you care, then you lower the 2.5 down to where? To 0. So the whole it becomes from 0 to 9.5. That whole area is your cavity ratio, room cavity ratio. Can I have thumbs up that we know, Chad, what the room cavity ratio is? Cool. Okay, room, ceiling, and floor. Okay, now we're going to go calculate that. We're going to go how to calculate these ratios. If you guys go back to where we're, here's an example that I have for you. Take this. I have a room for you. It's a 12-foot ceiling, actually. This area is called floor cavity ratio. This is room cavity ratio, and the top thing is ceiling cavity ratio. There are the height of the cavities. It's H, the height HF, a floor cavity. If it says HFC, floor cavity, HRC, this is the room cavity, and HCC is the height of the ceiling cavity. Can I get you to understand all these terminology that they use? So if I ask you, Nick, my friend, HCC equal to 2.5 feet, HRC equal to 7, and HFC equal to 2.5. Why do I care? Because there's a formula. I need to fill that formula down there to find the cavity ratio. So first they define cavities, then they define a term called cavity ratio. You know why? Why they're missing with all this? To find something called coefficient of utilization. They want to find a coefficient of utilization. Meaning, if I put this fixture in this room, how efficient is this fixture in this room depends upon how the room is painted, floor, ceiling, and walls, obviously, and also on the fixture itself, a couple of other characteristics of the fixture. So I'm looking for a cavity ratio, or coefficient of utilization for these fixtures. Okay, can I get you guys to understand this? This is a view of the ceiling, 2.5. The ceiling is 12, right? Right in here. Okay. Now take this. If you want to find room cavity ratio, here's the formula. Room cavity ratio always. You take 5. Why 5? The guys who created this formula found by experiment 5 works good. There's a reason why 5, but for 5 is a constant. Multiplied by. Actually, if you want to find the room cavity ratio, you're going to multiply by the height of the room cavity. What's the height of the room cavity? HRC, in this case, it's 7. Then you open the brackets, and you take the length, add it to the width of your room. This is length plus width of the room, divided by the length multiplied by the width of the room. If I have a room like this, guys, and I need to find the room cavity ratio for this room, you take the length and the width, multiply them by each other, then add them at the top. Then you take the height of the cavity, which is, in this case, 7, and then that will get you, if you do the math, let's take this example here. So I'm giving you guys a room right on this side, 20 by 30. Everybody can see that it's a room 20 by 30. So let's go apply this one. I have width 20. I have 30 plus 20. And this is 30 times 20, right? That's formula straightforward. What's the height HR based on this? I have to give you the height of the ceiling. Based on this criteria, what's the height of the cavity? 7. So multiply this one 7. So it doesn't take rocket scientists to take the 5 multiplied by 7, then add the 30 to the 20 and multiply it by the answer, and then divide it by 30 times 20. If you guys do the math, you should end up with 2.9. Any question how to calculate the room cavity ratio? The only thing that's going to change, when I test you, again, I hate to spend time on it even because there's a lot of softwares now, but this will help you understand how do they calculate the lighting indoor. The first step of calculating lighting indoor is to find the room cavity ratio. How do you find the room cavity ratio? In order to find the room cavity ratio, you need a room. So you need the length and the width of a room. Now, if your room is not rectangle, you kind of make it as rectangle as you can, So you need the width and the length of the room. Cool, that's easy, width and length. Then you need to define what is the cavities in your room. For example, if this is a hallway, guys, and I want the light to be at the floor, then what's my floor cavity ratio? Big fat 0, because I want to see the light at the floor. Then what's the room cavity ratio? It goes from 0 all the way up to 10 feet in this case. So my floor cavity ratio could be 0, because I care less about what's going. I want the light to be right at the floor. If I want the light to be right at 2.5, then I have to calculate my room cavity ratio, basically 2.5 all the way up to the ceiling. Any question, guys, about this?
So if we have a polygonal room, you assume it's to be rectangle?
For this formula to work. Or you have to kind of make it as rectangular as you can get. Don't worry, we have the software now that we can get into any other shape. But to use this formula, you have to at least have some type of a rectangular shape or square. Any question, guys, how to use this formula? I'm going to calculate room cavity ratio. This is the most important one. Then ceiling cavity ratio. Then floor cavity ratio. Now, for floor cavity ratio, what do you think the only thing that's going to change, guys, is the height. Everything stays the same. For all the cavities, everything stays the same. The only thing that's going to change is what? The height. So if I'm using the room, the height is 7. If I'm using the ceiling, the height is 2.45. And if I'm using the floor, the height is 2.5. Okay, let's go to calculate the room. Okay, the ceiling. I'm going to calculate actually the same thing for ceiling cavity ratio. Ceiling cavity ratio equal 5 times the height for the ceiling cavity multiplied by add the length to the width divided by the length times the width. Okay, 5. Where did the 5 come from? Constant. Where did the 2.5 come from? The height of what? Of the ceiling cavity. Thank you. Where did the 30 and 20 came from? That's the dimension of the room, Chad. Duh. Look at the cavity, the ceiling cavity ratio. Here's my ceiling cavity ratio. Let's go to the floor cavity ratio. Same thing. The only thing that changes, guys, the only thing that changes for the 3 cavities is this number. 5 times. Okay, let's go to the floor. What was the height of the cavity for the floor? 2.5. Multiplied by the same number. Give you 1.04. On the test, here's what Chad is going to do for you guys in the test. I'll put you these numbers at different, like I put you the first, the height of the floor cavity is 3. The height of the ceiling room cavity is 9, and then the height of the ceiling cavity is 4. And do the cavity ratio for each one of these areas. And it's a 50 by 50 room. Any question, guys, about how to calculate the cavity ratio? Not really, not a whole lot of rocket science. On the formula, Dustin, my friend, bring the formula with you. The only thing that changes is the height of the cavity. The height of the cavity. Okay, one more time. I want to show, in order for you guys to do this, I have to give you something like this. Right? In order to solve this problem, you need 2 things. You need first the dimension of the room, the width and the length. And number 2, you need the height of the cavities. What I'm showing you, Nick, here is the typical height of a cavity. That's what you do typically if you don't know anything. Okay, let's go change this one for you. And I'm going to ask you guys to tell me let's take this room. And I'm decided to use here. I'm going to cut it right here. And this is, I'm going to make it 2.5. And this area here, did we say 12? That will make it 9.5 feet. And I'm going to ask you the following. What is the floor cavity ratio? Just by looking at this. 0. What's the floor cavity ratio? 0. Absolutely. Why? Because the height of the cavity is 0. If you multiply 0 by anything, what do you get? 0. Just by looking at it. Now, if I ask you what's the room cavity ratio, no problem. You multiply, you put 9 in the formula, multiply it. What's the height of the ceiling? Ceiling cavity ratio, floor cavity ratio. When would you use this versus this? If your calculation, the dots that you calculated is on the floor, the calculation level, the calculation zone, you put it on the floor, right? Like we did in the hallways, calculation level on the floor. Then do I have a floor cavity ratio? No, 0. If I put my calculation zone at 2.5 or 3, then my calculation, then you have a room, a cavity, a floor, and a ceiling. Can I have thumbs up, Chad? We got that ceiling cavity. The most important one, you really don't need to know this, except for Chad for the test. The floor cavity and the ceiling cavity. The only one that you need to know is the room cavity, because that's the one that's going to determine how much fixture we're going to put in this room. You're going to see in a second. What I want you to tell me, guys, everybody knows how to calculate this based on this formula? Really not rocket science. I give you the dimension of a room and a diagram like this, and I ask you to find the room cavity ratio. And the only thing that changes is the height of the cavity. That's it. The formula stays the same. Rob, my friend, makes sense? Okay, so take this. So that's we know how to calculate the room cavity ratio. We know what it means. Now let's go down to an example. Let's take an example. Now the reason for this one room cavity ratio, guys, take this example. And this is, I want you to wake up if you're sleeping. I'm asking you to find, this is called the average method. Let's use the average method. You guys remember the foot candle equal the fixtures, the lamps, the lumens, multiplied by light loss factor, multiplied by coefficient of utilization, divided by the area. Remember that rule, that formula? This is the average method that we used. This is the rule that we have used this formula before. So I have lumens times lamps times fixtures times light loss factor times coefficient of utilization. All the junk that I've been telling you for the last 15-20 minutes, guys, the coefficient of utilization, all of this to help me calculate the CU, the coefficient of utilization for this fixture. I used to give it to you in the formula. Now you need to calculate it. Okay, so take this. I'm giving you an area, guys. I'm giving you an area. This is an example. I'm giving you an area, 20 by 30. Cool. And I want to put 10 fixtures on this area. I'm giving you how many fixtures I want. I want 10 fixtures. 1, 2, 3, 4, 5, 5. 10 fixtures, right? 10 fixtures in the area. 10 fixtures, 2 by 4, in a 20 by 30. And I'm asking you, please, to find the foot candle for this. One more time. I'm giving you an area 20 by 30, and I'm putting my fixture this way, and I want you to find the foot candle. But I have to give you something about the foot candle. I'm giving you that each one of these fixtures has 3 lamps, and each lamp has 3,000 lumens. Cool? Right above your head. 3,000 lumens, 3 lamps each. I have 10 of them. I'm giving you that there have 10 of them in this room. Could you please find me the foot candle for this area? Okay? You guys have done that before with me. The only new thing that got introduced here is to find the coefficient of utilization, the CU. Okay? All right. So to find the CU, I don't know if I have it in the second slides. Find the CU. No, that's exam number 2. Okay, to find the CU, guys, you need to, for 20 by 30, we need to find the CU for this room. Got it. There you go. The same, I want to use, actually, I'm using the same, here's my 20 by 30 room. Remember that 20 by 30 room, guys? 20 by 30 room. This is the ceiling in that room. I decided this is how I'm going to put the ceiling in that room. So the first thing I need to do, the first step you need to do when you have to find the coefficient of utilization, you're giving the area, you're giving the heights. I need to find the RCR, the room cavity ratio. Any question about 2.9, where the 2.9 came to be? Any question about how to find the 2.9? 2.9. So take the 2.9, the room cavity ratio, take it all the way to the same example. Now that we did, so here's my room. I need to find the coefficient of utilization. The whole mess is to find the CU. Okay, so what's my coefficient? What's my ratio? Room cavity ratio, 2.9. Where does the 2.9 came to be? From this room, based on the height that I gave you. Okay. This is where you're going to be using a few things, guys. Take this data, and based on a floor reflective factor from the floor, reflective factor from the ceiling, reflective factor from the floor, ceiling, and walls. These are floor, ceiling, walls. So do me a favor. I want you to go, please. Let's go to page 84. And let me show you how to find the coefficient of utilization for this fixture. We came up with coefficient of utilization 0.6. But how did they come up with 0.6? How did they come up with 0.6? Okay, take this. Everybody's looking at this. Everybody's looking at that page 84. Page 84. Okay, page 84. Okay, the first thing, if you guys look at the top one is called the floor RFC, the floor reflective factor. Can you guys, am I giving you floor reflective factor is what? 20. Can you guys see that? 20. Can you guys see at the top of that table, it says 20? Cool. All right, so we have only one choice, 20. For floor, what this means actually means we're expecting 20% of the light that hit the floor to be reflected back into the 2.5 calculation level. Make sense? 20% of the light that comes out of this fixture hit the floor is going to bounce off the floor and come back into the calculation zone, which is 2.5. Cool? Okay, so this, by the way, these 1, 2, 3 are given. These are all given. All right, so a 20% reflective factor from the floor. The second one, ceiling. Ceiling reflective factor is 80%. Now, you have two options. Can you guys see the options I have? I can either go 80 or 50. So I am telling you, because my room is painted, goes by paint, guys. It goes by paint. How would you make it, how would it be 80 or 50? If this wall is white, the wall is painted with white will reflect most of the light. So that will be 80%. If this is a dark color, this will reflect anything other than white or lighter color is going to be 50. Okay? So I'm telling you it's going to be a lighter color painting. So I'm telling you I'm going to paint the wall with lighter color, white or any lighter color. Then the reflection is going to be 80. So go to the section that says 80. So what this means, you're going to ignore the 50. Can you guys see the 50 is gone now? I don't want to look at the 50. All right? Are you with me? With the ceiling, with the floor? The last one is wall reflective factor. Can you guys see what it says wall reflective factor? I have, that's the ceiling. I'm sorry, the first one is ceiling, which is the ceiling, is it white or not? The walls, I have 70, 50, 30, 10. 10 is black wall. You put a black wall, you're 10. 70, you put a white wall or any good whitish color, you're going to be a 70. So I'm telling you it's going to be a 50, right? So right somewhere in between, 50. So you're going to go under. So based on these, can you guys see which column am I looking at right now here? 50. Everybody's at 50 column? Right here? 50. And I need to cross-referencing it with a 2.9. Can you see, guys, in the first column is RCR. Is that familiar with you? Is that familiar to you? This is the room cavity ratio. Based on the room cavity ratio and the reflection, I can find the coefficient of utilization. Take this. So mine is 2.9. So actually, I don't have 2.9. We're supposed to do interpolation, but I don't want you to do interpolation. Go to the closest. So Jackson 2.9 becomes 3, right? So guys, go cross-reference the 3 under 50. What do you get from 3 under 50? 0.60. So the coefficient of utilization for this fixture, is 0.60. See why we missed with the whole room cavity ratio? That's it. In the past, guys, when you were with me, I used to give you that coefficient of utilization. I said, here, take it. Now you're going to calculate it. So for 0.6, now what do? You put the 0.6 here. How many foot candle do we have here? 74 foot candle. Any question? Okay, let me just get you to use that table, because I feel. Let me just get you guys to use that table for 1 second. If I have a room cavity ratio of 9, floor R floor as 20%, and ceiling R CC reflection from the ceiling is 50%, and R reflection from the floor as let's just say 10. Can you guys find me the coefficient of utilization based on these criteria? Let's do it together. And I'm asking you to find coefficient of utilization for this fixture. Okay. Can you just see the RCR? The first number is 20. I have no other option, right? 20. The second, I have 50. The reflection from the ceiling is 50. Everybody can go to the other set of columns, 50. RCC is 50. Now the walls are also given as 50. So go cross-reference 50 with 9. Anybody can give me what the answer is? Huh? 0.29. I'm giving you a room cavity ratio of 9. What's the answer? The room cavity ratio, guys, the one on this column, right here. This should be 9.
0.16, right? Yeah.
So if you go 9 cross, it should be 0.25. This column, guys, this one here, on this column. Cool?
You said that the room cavity ratio is 50%.
The room cavity ratio is 9. The reflection from the ceiling is 20%.
Okay.
The reflection from the
You mean
the floor, the ceiling is 50. The walls are 10.
Yeah, so it should be it should be 0.16 because you have to go way over to the 50% column.
Okay, 20, 50, under 10, and what did you say?
I'm just following you.
Yeah, go ahead. What's the?
It's way up to the
Yep.
right-hand side.
What's the answer?
0.16.
And the answer is 0.16. Yep, I was looking at the extreme. 0.16. Thank you.
All these tables are different. Like build this. It's understanding the table that's the challenge.
Here's the table. Let's go to a real fixture. Let's go to a real fixture, guys. Could you please come with me here? Take this. Can you guys this is a fixture, a real fixture that comes, this table comes with it. It's GT8. You guys used it in our project. Cool. GT8 2x4. Let's do GT8 2x4. Okay, let me see if I can do that one here. I want to synchronize. Okay, so here's a fixture. This one, guys, is GT8 directly from Lithuania. Cool? Are you with me? I want to remind you there's multiple of these curves. Why? Because everyone have different lamps. This is a 4-lamper. I decided to use this one. It says TGT 8-4-32-8-12-1-4. So it's a 4-lamp 32 watt, exactly like the one above your head. GT8. Cool? Fixture. All right, so let's, here's what you're looking at. The first thing is we have ceiling. We don't have a floor here. Do we have the floor? We have the ceiling, coefficient of utilization. I have a ceiling and I have a wall. The floor is, remember the floor was only one assumption for it, so it doesn't make a difference anyway. Okay, so let's say I needed to have a very dark wall, right? Very dark wall. Very dark wall. Here's my dark wall, 50. Can I have thumbs up, guys? Yep, dark wall 50, Chad. I picked the dark wall, 50 for it. Okay. And the walls, I'm sorry. My ceiling, I'm going to paint it dark, so it's 50. I picked the 50. Now I'm going to go to a wall, the wall right underneath it. So what type of, do you guys want to, my option is 10, 30, 50. 10, 30, 50 here, right? That's my only option under these. So under here, here's my options because I decided. So I'm going to go to also 50. Okay, cool. 50, 50. Now, the only difference now is the coefficient of utilization. The only difference is the room cavity ratio. Now, for the same room, the room that we did, guys, suppose my room cavity ratio was 2.9, which becomes 3. Okay? So let's go to 3. Here's a 3. And that will take me all the way to, what's my coefficient of utilization? Coefficient of utilization, 0.61. Coefficient of utilization, 0.61. Any question how to use this table? Any question, guys? Complicated? Yes, no? Any question how to use this table? So the whole idea, guys, Rob, my friend, is you go find the RCR. From the RCR and the reflection, you find the coefficient of utilization. Dustin, does it make sense? Nick? Yes. Aladipo? Is it confusing? Confusing? The only thing you calculate is the room cavity ratio based on the calculation, and then you have to make a decision. Am I going to put, what type of color am I going to put in for this fixture? What type of color do I want to put for this fixture? What type of color do I want to put for the ceiling and the walls? If it's light color, you put the higher number. If it's dark color, you put the lower number. Now this is coming from GT8 fixture or 2GT fixture, but it could be for any other fixtures. Why do we have multiple of them? One for how many lamps you have. Can I get you guys to understand that based on the room cavity ratio without a curve for the manufacturer like this, I can't do anything. Based on the room cavity ratio, that's the only thing I can control. I can find the coefficient of utilization for this fixture. Okay? All right, so let's go here. Let's go back. Okay, any question, guys, where we came up with 0.6 for the test? Here's what I'm going to tell you. I might ask you, give you the fixture. You go to the formula from this schedule, you find the coefficient of utilization. I'm usually this brutal. What I do is I print the curve for you that you guys are looking at. It's called coefficient of utilization curve here. I will give you a copy, and you guys will calculate the room cavity ratio. I will give you the reflection of the ceiling, the floor, and ceiling, floor, and walls, and based on this you find the coefficient of utilization for the fixture. Okay, so we found. Any question, guys, how we came up with 74-foot candle? 74-foot candle. Take the second example. Here's another example. How many fixtures this time? How many fixtures? I'm asking you guys how many fixtures I need for a room. Take this room. Given I have a room of 40 by 50 by 12. 40 by 50 by 12. Similar to this room. I decided single-handedly, Chad Curdy, to use 4 lamps. The foot candle that I want to maintain is 60. The lumens is 4,000. And the light loss factor, I'm giving you 85. And I'm asking you guys to find how many fixtures do I need. Everything is given. I'm also giving you the floor. Reflection of the floor is 20. And reflection of the ceiling, it's a dark ceiling, 50. And reflection of the walls is 10. Very dark wall. Cool? All this, everything here is given. Everything here is given. And I'm asking you how many fixtures of this type, under these circumstances, do I need for this room? Any question? And to add it up to this point, actually, you look at me and say, Chad, okay, your ceiling is 12. I don't know how you're going to divide your cavities. Could you please tell me how you're going to divide your cavities? I said, no problem. My cavity is going to be divided this way. I'm going to do my calculation based on this area here. This is my calculation zone. So 2.5 and above, and 3. I care less about the last 3 and the first 2.5. And I want my room cavity ratio to be between 2.5 and basically between these two numbers, which is 6.5. The reason why the most important cavity, guys, is the room cavity ratio. Ceiling and floor done. We don't care about them. Okay, let me repeat myself one more time. I have a room of 40 by 50 by 12 height. I want the cavity ratio to be as shown. Basically, the height is 6.5, right? I have to give you this. And I'm giving you all the foot candles. The lumens is 4, the foot candle 60. Foot candle 60, lumens 400. Losses is 85. And that's up to this point is not enough. You can't solve the problem. You still need to see what type of paint are you painting the ceiling, the floor, or the ceiling and the walls. I'm telling you that my floor is 20%, so it's dark floor. Not a whole lot can be reflected from the floor though. Ceiling 50, so it's somewhere in between dark and light ceiling. And my walls are 10%. My walls are 10%. So they are dark. Okay? Any question about what the given is? What's given? Any question about what's given? All right, let's go solve this problem. The first thing you need to do is find room cavity ratio. So what do you do when you find the room cavity ratio? You take the 5y. Why 5? 5 is always there, constant. Thank you. What's HRC? That's the height of the room cavity, which is 6.5. 6.5 multiplied, make sure this is a brackets. Width, length. So 5 times 6.5, 40 plus 50, 40 times 50, you do the math, and you end up with 1.46. You end up with 1.46. Any question, guys, how to do this part of the equation? How to find the room cavity ratio? Right? Here's the ceiling, plug in the 6.5. Do I care about the ceiling cavity ratio or the floor cavity ratio? Out the window. I don't care. If I ask you for the test, I will. If I ask you for the test to find them, what do? Instead of 6.5, you just put 2.5 once. Here's the floor, and you put 3, and here's the ceiling. Really not a whole lot to it. If you're not good with math, I will remind you that you first, when operate, what do you call it, order of operation always the brackets. So when you do the calculations, you have to add what's inside the brackets, or the parentheses, and then you multiply. I have students, guys, multiplied the 40 by everything, and then they added 50. Order of operation. Parentheses always comes first, right? And then multiplication, division, multiplication, plus, minus. Okay, any question, guys? Now, Ashley, if you look here, I have 1.46. Because we don't want to do interpolation, go to the closest. The closest, if it's 1.5, I will go to 2. If it's 1.46, I'll go to 1. So round up to 1. I rounded up to 1. I don't have to, just because I don't want to do interpolation. So everybody knows where I came up with 1. If it's 1.5, go to, less than 1.5, go to the lower. Okay, any question? Now, I want you guys to do me a favor. Based on this criteria, go to the same page right here in our book, and let's find what's the coefficient of utilization for this fixture. So I have 1. Can you guys look where 1 is? Room cavity ratio. And I have 20, 50, and 50 and 10. So anybody can give me a number? 0.65. Anybody come up with a different number? Okay, 20, yeah, 50, 10. Makes sense how you guys go from one column? The first row is going to be 10, 20. The second row is going to be 50. So go all the way to the right. And the second row is going to be 10. So I have a 0.65. I have a 0.65. Can I have thumbs up, Chad? We know how to do it? Cool? Okay. So based on this criteria. Okay. So based on this criteria, guys, and from this figure that you're looking at, the coefficient of utilization for this fixture is 0.65. Can you guys let me know if you know how to find it, Chad? We're good. So what I'm going to do for the test, I'll grab one of these Lithonia ones and highlight the fixture for you and say, the only thing is not there is the floor. Who cares? The floor is only one number anyway in this sheet. And you can find the coefficient of utilization for this fixture. based on the room cavity ratio, the ceiling, and the wall reflection from the ceiling and the wall. Okay, now that we found it, do you guys not know how to flip the formula to find the number of fixtures? This is the formula, the average method to find the number of fixtures. Foot candle times area divided by lamps, lumens, light loss factor, and so-called CU, the coefficient of utilization, which we have just calculated. So Ashley, I'm asking for 60 multiplied by 40, 50. Divide by all this. That will get you 14 fixtures. That will get you 14 fixtures. One more time. If you guys look at what I'm asking you, given all this and the layout, can you find me how many fixtures I need for this room? These are the criteria. I need just how many fixtures. Now I know visual will do that one in a heartbeat for you. And that's what we do. Now to do it by hand, first I want to remind you, you have to decide what type of fixture you want to use if you don't have visual. Well, even with visual, we have to decide what type of fixture we need to use. You can't just, I decided to use 2x4 traffer, 400 lumen in each one of these lamps, and 4 number because it's the most economical way of doing it. Why 50? Foot candle 60, typical in classroom, 60 to 70 is typical. We'll say it's classroom. I need 60. So these are the criteria. This, you do the calculation piece of cake here. From here, you round to the nearest, and then you go. You have to have this fig. Without that fig, that Chad is going to give you in the test, you can't do the math. From this fig, you find the coefficient of utilization. Now, piece of cake, Chad. Here's the formula they're going to bring with you to the test. You grab this formula, plug in the numbers, 14 fixtures. 14 fixtures. I need 14 fixtures in this area. Any question, guys? I want to remind you this will be PDF and on the network for you too. Any question? No, makes sense? No? Okay. Now that I know how many fixtures I need, guys. Now that I know how many fixtures I need to lay them out. I want you also to be able to lay out fixtures. So remember, Ashley, I have 14 fixtures. How would you lay out a 2x4 14 fixtures? You're going to lay them out, and the rule, guys, is you need to lay them out with the same number of rows and columns. But obviously, to do that, you're going to take the 14 and ask yourself, what are the 2 largest numbers that I multiply by each other to get you with 14? I can go 14 by 1, 40 rows and 1 column. That will sound weird. Or I can go 14, my second option is 2 by 7, right? This is factoring numbers. You guys know how to factor 4? If you have 8, you go factor 2 by 4, and then 4 is 2 by 2, right? So you're going to ask yourself right here is the number of fixtures. What are the 2 largest numbers that I multiply by each other to give me 14, which is 7 by 2. You're going to say 14 by 1. Oh, that's the largest in both sides. Ideally, Ashley, I want the number of rows and columns to be the same. So ideally, I really would like to see 7 by 7. But I can't find 7 by 7. For example, if you have 25 fixtures, that's a perfect distribution. 25 fixtures, that would be 5 times 5. Awesome. If it's a square, it's awesome. If it's not a square, you're going to get basically as good as you can. If my option are 17, 14 times 1, or 2 times 7, it's going to go 2 times 7. Can I have thumbs up? Yeah, we got it, Chad. Okay. All right, so here's my 7. So then I'm going to go draw them, orient them. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Cool. 7 in each row. Now I need to find, this one is to find the best distribution. Then the next step, guys, when I found how many rows and columns, and if you came up with 14 times 1, that's not wrong, but that's not the best scenario though. Okay, take this. Now I have a 50 by 40 area, and I'm going to orient them. The distance, the code says the best distribution for fixture, guys, is if the distance from the fixture, from the wall to the fixture, is half the distance between the 2 fixtures. Look at these. From the wall to the fixture, x, between the 2 fixtures is 2x. or if this is x, this will be half an x. That's the best distribution to get even distribution of foot candle. Okay, so if you guys orient them this way, this becomes an x because I have no idea how far to the center. By the way, we're going to the center of the fixture, to the center of the fixture. So this is x, then between the two fixtures is always what? Twice that, 2x. 2x, 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 all the way up. And in the y direction, it's also to y to the center of this fixture, from this fixture to this fixture center-wise, 2y. Any question about, and we did an example like this, guys, before too. What I'm doing, guys, is after I decide how many fixtures I need in an area, I need to lay out my fixture in a way that get me the best lighting distribution system. Best lighting distribution system happen when your fixtures are equally distributed all over the space. How can I find that though? I need to give it to an electrician to install this. You can't just put it on a piece of paper here and say, well, do it. You need to do the calculation to find the orientation of each one of these fixtures, as well as the x and a y for every fixture. Okay, can you guys give me a thumbs up? We know why x and 2x between them, guys, at the top, and we know why y here, and we know why we have 7 columns and 2 rows. You're going to have more columns or rows based on, so why didn't I put the columns this way? Why didn't I have instead of 7 columns, 7 rows and 2 columns? The number, take this, Ashley, the largest number will go with the largest dimension. Can you guys see that? 50 is more than 40. So my 7 here, this will mean I need 7 columns, not 7 rows. The 2 goes with the smaller dimension, which is the 4. Now, if you have a square, doesn't matter anyway. Okay, any question, guys, about the orientation? Cool. Then you take the x's, take your x's, you have 7 times 2x, y 7. You count all your x's here. You're gonna have 7 2x's. Put it this way. Oops. Doesn't even orient it. There's 2. Why? Because here's 1, 2, 3, 4, 5, 6, and there was 1 x and 1 x here, 2 x's, 7 2x's, right? 7 2x. Where's the x chat done? 2x. If you don't wanna believe Chad, what do? Go count the x's. 14 x's equal 50. So here's 14x divided. So the x is 3.5. So Ashley, from this side, I'm gonna move 3.5 feet and make sure that's the center of my fixture. Now some of you say, Chad, there is a grid there. Yeah. Then if that doesn't hit the grid, then you're gonna orient yourself in the grid. That's your start point. Obviously, you're not going to go bust the grid and move it to the other side. This is your start point though. This is your start point. So most likely, if I have a grid exactly like this, so 3.5, this is 4, I need a 3.5, so most likely my first fixture, because I can't, is going to be right in this area here. Okay, any question guys about this? Then what's the distance between the two fixture to fixture, center to center? 7. So I'm going to go 7 feet, center to center, and go to the fixture, 7 feet. Right now, the way these fixtures center to center, guys, is 4 feet plus 2, 8. They are 8 on center. Can you guys see that? Right above your head. This is 8 on center right now. Right? On center. All right, so I have 7 on center here. Now, if I can't get the 7 on center because of the orientation of the grid, what do? Go 8. Okay. Any question about the x? Let's go to the y. The same thing for the y. I have 4 y's. 2, 3, 4. 4 y's. 2 plus y equal 40. 4 y's equal 40 divided by 4, 10. So the distance, the y, is going to be 10. So I have y is going to be 10. In between them, there will be 20. In between them, there will be 20. So from the y side, you're going to go 10 feet with the first fixture, and between the two fixtures, this way, it's going to be 20. Any question, guys? How to find the x and the y? On the test, you will have a problem exactly like this, and I will ask you guys to find the best distribution by finding the rows and the columns, and find the X and the Y for one fixture. I care about one fixture. Find me the X and the Y for this fixture. Then from there, I can build the system, right? If I want to find where this fixture is going to be located, I know it's going to be 10 feet this way, and you multiply 7 plus 7 plus 7 plus 3.5. Add them up, you find the orientation of this fixture. Any question guys about how to orient your fixtures? Cool? No? Okay, so that's this is just going through a couple of examples that I did with the students, guys. If you have 40 fixtures, to find how many rows and columns, here's your option. You go 40 times 1, you will be a fool. Or you can go 10 times 40, that's another option, right? I mean 10 times 4, 8 times 5, or 20 times 2. Is there any other option to get 40? These are the 4 options of getting the number 40. If I have a 40 fixture and I will put them in a place, I can either put 4 columns in 1 row, or 10 columns and 4 rows, or 8 columns and 5 rows. The best design, Nick, is to get the closest, the columns, the number of the columns and the number of rows have to be as close to each other as possible. For example, I can go 20 and 2, they're way far away from each other. The closest rows and columns are the 8 by 5. If you put 10 by 4, is it wrong? No, but there's a better way of doing it though. Can I get you guys to understand the columns and the rows? So from the number of fixtures, you can decide the columns and rows. Here's another example. The other example is, what if I came up with 41, Chad? 41 is a prime number. Remember the days of the prime numbers? Prime number. A prime number cannot be divided except by itself and 1, right? That's what a prime number is. So there's no 2 numbers that you can multiply to get 41 other than 1 and 4, or 41. So what am I going to do? So am I going to have 1 row and 41 columns? Fool. So what I suggest to do is add another fixture. In this case, I have 41. I'm going to make them 42. Now remember, if you don't have a software, if you have a software, you can readjust it. I don't have a software. So 42, you agree with me, for 42, the best scenario will be 6 times 7, right? Though you can, 42, you can have 21 times 2. Not a good idea. So 21 times 2, 41 times 1. That's the only way you can get 41. So the best scenario would be in this case is what? 6 times 7. Why? The number of the columns, the number of the poles, the number of columns, number of rows need to be as close to each other as practical. Any question? Now, the question would be then, some of you guys will ask, what if I have a circle? What if it's not a square, Chad? What if it's not rectangle, right? What if the area is not a square? What if I have a room like this, right? A little indent in the room, square the area or rectangular. So make approximation. So here's a circle. I can draw a rectangle that covers most of the circle and do your calculation based on that rectangle, guys. And when you're done, if you end up with a fixture that's located right in here, when this is a wall, move it. Bring your fixture here. It will give you, Rob, my friend, a good starting point for any shape. If your shape is not a rectangle or a square, which is a special case of rectangle, right? Then make a rectangle around it, enclose it with a rectangle, to the best of your ability, and do the calculation based on rectangle, columns and rows, and then lay them out. Then you might have to shift certain things to fit in the shape of your room. If your room is like this, guys, see that little niche here? Exactly like here. If I'm going to do it in this room, I will just assume this doesn't exist. And I do my calculation on a rectangle room exactly like that, without taking into that little indent into consideration. And then if one of the fixtures end up right there, what do you do with it? Move it. Any question, guys, about using this method to calculate? So get that. That's all I have. Any question? Is it hard, guys? Just to review, all I want you guys to take from this today is how to calculate the room cavity ratio. You have a formula. From the room cavity ratio, you can go to the room cavity ratio table and find the coefficient of utilization and find the coefficient of utilization for the fixture. And from there, you can do two things with it. You can find how many fixtures you need in one area, or you can find the foot candle in one area. Foot candle, the same formula, find the foot candle in one area. And both of what I told you is called obsolete. We like to throw them here because we teach you basic lighting. But if you do this one, a company that I belong to, you wouldn't last for long. But knowing the basics, guys, will help you understand how to lay out your fixtures. When you do it in visual, that 1x, 2x between the fixtures and 1y, 2y, it will help you lay out your fixture better. Can I have thumbs up, Chad? We got it for Monday. Dustin, my friend, yes, no? And as I showed you guys, all the fixtures that you're going to have, every fixture, indoor, it's going to have a cable like the table like the one. So here's a table, one similar to what we did, 3 lamps, for example. And you have the ceiling reflection right in here. I don't know if you guys can see it. And right underneath it, the wall reflection. And then the column right here will give you the cavity ratio. This is my cavity ratio right here. From these, you can find the coefficient of utilization. Now, what is the coefficient of utilization? How efficient the fixture is going to be within these circumstances. It's not enough by itself, guys. It's not just a factor of a factor of fixture and the room, the ceiling, the floor, reflection, and so forth. That's why we didn't do that when we were doing outside light. We didn't care about this because there's no walls, so to speak, and ceiling in a parking lot to reflect. And the floor, the ground of the parking lot is negligible. You neglect the reflection. Most of it dark, most of it at night, not going to reflect a whole lot. Any question, guys? Okay, that's all I have for you.